Okay, lesson 8.1, single payment loans. The objective of the lesson is to compute the maturity value and the interest rate of a single payment loan. A single payment loan is a loan you repay with one payment after a specified period of time. A promissory note is a written promise to pay a certain sum of money on a specific date in the future. If at any time you need to press pause or rewind, please do so. Okay. Now, the maturity value is the total amount you must repay for a loan. The term is the amount of time for which a loan is granted. And we have two types of interest. We have ordinary interest, which is interest on a loan calculated by basing the loan's time period on a 360-day year. The other type of interest is exact interest, where it's interest on a loan calculated by basing the loan's time period on a 365-day year. Okay, we've got four formulas. The first formula is to find interest. It's just principal times rate times time. Now, for ordinary interest, it's the same formula, but for your time, you divide it by 360. Okay? Exact interest, it's time divided by 365. And to find the maturity value obviously is how much you have to pay back in total, is the principal plus the interest. Okay. Anita Sloan's bank granted her a single payment loan of $7,200 for 91 days to pay for new merchandise for her candle shop. Determine the maturity value of the loan if the rate is A, 6% ordinary interest, or B, 6% exact interest. Okay, so let's do A first. We need to find the interest, then we can find the maturity value. Okay, so in order to find the interest, we take the price of the loan times the interest rate of 6% times, since this is ordinary interest, it is out of 360. She has 91 days to pay. So 91 over 360. Now, when you find a problem like this, or multiply, you always take top times the top, bottom times the bottom. So, we're going to put understood ones under the 7200 and the 0.06. Go ahead and multiply on your calculator. 7200 times 0.06 times 91. You should come up with 39,312. 1 times 1 times 360 is 360. Okay? Divide that out. 39,312 divided by 360. Your interest equals 109.20. Now, in order to find the maturity value, all you have to do is take the principal amount of money that you borrowed, $7,200, plus the interest that you just found of $109.20. Add those two together, the maturity value of with the ordinary interest is $7,309.20. Okay? Let's go ahead, let's find the same thing, but using exact interest. Okay, so let's go ahead. I'm going to shrink this down, put it over here to the side so I have some more room. Okay. Part B. We have 7,200, again, times 0.06 times 91 days divided by, this time is 365. Okay? Again, it's top times the top, bottom times the bottom. I'm going to go ahead and put my understood ones under there so you know I'm still multiply by those. Equals 39,312. That number did not change any. Divided by 365. 39,312 divided by 365 works out to be 107.70. Okay, that's my interest. Now, to find my maturity value, again, take the principal amount, 7,200, plus your interest that you just came up with, 107.70, and you end up with 7,307.70. Okay, let's go ahead and let's continue. Now, these problems are straight off your homework, so press pause. I'll give you a second to do them yourself, and then let's make sure you did them right. Okay, let's go ahead and work these. Number one, Parker Logan purchased a new surfboard costing $600 and financed it at 9% ordinary interest for 90 days. Okay, so we're going to find our interest first. The surfboard costs $600 at 9%, and we're doing 90 days of ordinary interest. So, times that by 90 over 360. Okay? So, in your calculator, should have put 600 times 0.09 times 90. You should come up with 4860 over 360. Remember, top times the top, bottom times the bottom. Okay? 4860 divided by 360 gives you interest of $13.50. Now, in order to find the maturity value, take the price of the original item plus the interest that you just came up with. Your maturity value is $613.50. Okay? All right, number two. Holmes Ostendorf added a tack room to his barn costing $4,850. Financed it at 7% for 120 days of exact interest. All right. So 4850 times 0.07 times 120 gives us 40,740 divided by 365. My interest that I come up with is 111.62. Okay? Now, the B part to this is the maturity value is 4850 plus 111.62. Okay, should have got 4,961.62. All right, moving right along. Okay, now, I know you most likely cannot see this on the computer, but this table, I assure you, is in your book. It is the elapsed time table on page A10 in the back of the book. You will need this information for this next problem and several on the homework. Basically, if you get a loan on one day and you have 90 days to pay it off, you figure out if you bought something on February 20th, okay? That's the 51st day of the year, and if you have 30 days to pay it off. 51 plus 30 is 81. That note is then due on March 22nd. Okay? Pretty simple table to use. You will have to use it for these next couple. Okay, Claudia Valdez took out a single payment loan for $1,500 at 7.8% ordinary interest to pay her federal income tax bill. If the loan's maturity value is $1,529.25, when would Claudia have to pay back the loan if she took it out on March 1st? Okay, so what we need to do is find out how many days it took her to reach a maturity value of $1,529.25. In order to do that, we must first figure out my interest. So, $1,529.25 minus the loan amount of $1,500 gives us $29.25 in interest. Okay? Now, since we already know that my formula to find ordinary interest is principal times rate times time, we can just solve for the time. 29.25 equals the principal amount times the percent, 0.078, times, now I'm going to use D for days so I know how many days. This is ordinary interest, so it's over 360. Okay, multiply the same that we've been doing, top times the top, bottom times the bottom. 1,500 times 0.078 times D gives us 29.25 equals 117 D. Okay? I'm sorry. Gives us 117 D divided by 360. Multiply both sides by 360. 360 is going to cancel on the right side. Now 360 times 29.25 is 10,530 equals 117D. Divide both sides by 117. And you get 90 equals D. So that means that she's going to pay off her loan in 90 days. Okay? They want to know when would Claudia have to pay back the loan if she took it out on March 1st. Well, let's look at our table. If we look at our table and we find out March 1st is the 60th day of the year. Okay? If we take 60 plus 90, we end up with 150. Okay? So the 150th day of the year is when she needs to repay her loan. Go back to my table, find 150, here it is. She must repay her loan on May 30th. Okay? So the answer to this question is May 30th. Okay? Okay, moving right along. Number 3, this is on your homework. How long would it take a construction loan for $548,048 to earn interest of $50,000 at 9% exact interest? Press pause. When you're finished, press resume play. All right. Now, problem number 3 is a little different from the last one we just did because we already know our interest. We don't have to find the interest. It is set up the same way. The only difference other than that is this one is exact interest. Okay? So, 50,000 equals $548,048 times 9% times, we're looking for the number of days over 365 because it is exact. Top times the top, bottom times the bottom. Let's go ahead and multiply everything together. We end up with 50,000 equals, okay, 548,048 times 0.09. 49,324.32D divided by 365. Go ahead and multiply both sides by 365. Okay, it's going to cancel on the right. 365 times 50,000. Nice big number. 18,250,000 equals 49,324.32D. Divide both sides by 49,324.32. Again, it cancels on the right. You end up with 370 equals D. So, problem number 3, the answer is 370 days is how long it would take a construction loan to earn an interest of $50,000. Okay? Your assignment is lesson 8.1, page 306, 1 through 13, 17 through 18. If you need to, rewind and view the video again, or see me if you have any questions.